Hi guys, this lesson 8.3, is called Multiplying Polynomials. We already started doing a little bit of multiplying in the last lesson, but in this lesson we are most specifically going to be working on multiplying binomials. There are several ways of thinking about multiplying binomials. All of them are ways of accomplishing the distributive property, which you're already familiar with. But today I'm going to be specifically showing you a method called FOIL. FOIL just stands for first, outer, inner, last, and I'll demonstrate what that means. If I want to multiply two binomials, and here's an example, 2x plus 3 times x plus 5, and notice that there's no plus or minus between the parentheses there, so we know we're multiplying the 2x plus 3 times the x plus 5, and when we do this, the distributive property tells us that every piece, for example, the 2x here, has to multiply times both of the items in the other parenthesis, and then the 3 also has to multiply times both of the items in the other parenthesis. So one way of accomplishing this kind of neatly is to do this technique called FOIL. So the F stands for first, and we're going to draw a little arc from the first term of the first parentheses to the first term of the second parentheses. So first, this is F, first, we're going to do 2x times x. 2x times x is 2x squared. Okay, so the first in this case is going to be 2x times x. Then we're going to do the outer, O stands for outer, so we're going to draw underneath from the 2x all the way over to the 5. So the outer is going to be 2x times 5. 2x times 5 is 10x. And then we're going to draw the inner, which is I. We're going to go from 3 to x. Those are the inner terms. So if 2x and 5 are the outer, then 3 and x are the inner. And we're going to do 3 times x, which is 3x. And then we're going to do L for last. We're going to go from the 3 to the 5. And if you look at this, it has kind of made a funny looking face with a very large nose in the middle and 2 ears on the side. Kind of looks like a little cartoon character. So I draw this every time. It helps me to keep track of things. Let's finish this L. 3 times 5 is 15. So notice that I have done 4 multiplications. First, outer, inner, last. Typically, we will be able to combine the outer and the inner. This outer and inner thing becomes very key to some things we're going to do in the future. So FOIL helps us to look at outer and inner together, and outer and inner often either cancel each other or combine because they are often like terms. This is not always true, but in the types of really nifty binomials that we tend to multiply, very often something special happens with the outer and the inner. In this case, what we see is 10x and 3x can combine. So we have 2x squared plus 10x plus 3x is 13x plus 15. And then we are done multiplying our binomial. And we have 2x squared plus 13x plus 15. When we multiply two binomials that are linear, and 2x plus 3 is linear because the x has an exponent that's a 1. 2x plus 3 is a line. It's a linear, a one-dimensional situation, and x plus 5 is also linear. There's no exponent higher than a 1, and so x plus 5 also makes a line, but when we multiply these two one-dimensional situations, we end up with something that is squared. It's kind of like when we multiply inches times inches, and we get square inches. It's because we've done something like this, maybe 2 inches times 2 inches will give us 4 square inches, and we've seen that happen before with our units, feet times feet. Both of those are linear. When we multiply them together, we're now talking about something squared. We're talking about an area and not just a linear situation. So we're going to move into talking about quadratics. That's what we called something that is a second degree polynomial in just a little bit, but be thinking about these two linear situations multiplying together and then making a new situation that is second degree, or we also can think of that as now an area, or a length times a width, which makes an area. Let's work a couple more problems until we're a little more comfortable here. Our second example is this: x minus 2 times 3x plus 4, and we can jump right into FOIL. So we're going to do first, okay, there's our f, our first term is x and 3x. X times 3x is 3x squared. And then our outer, we're going to jump down here and do the very bottom all the way from the very first to the very last, the two outer terms. This is O, and x times 4 is 4x. And then we're going to do our inner, our I, that's the very innermost terms. We're going to have negative 2 times 3x, which will give us negative 6x. And then we're going to do last, the very two last terms. We've done first, outer, inner, last. The last term is negative 2 times 4, which is negative 8. Okay, we're going to give it a check to see what can be combined, and notice that very often in the middle, the outer and the inner terms will do something special. So 3x squared doesn't have any friends, but 4x and negative 6x can combine to make negative 2x, and then negative 8 doesn't have any friends either. So we have multiplied two linear binomials, and they have made one second degree trinomial. And we're going to have fun with that later. The leading coefficient is 3, that's going to be significant. And the constant is negative 8, that's also going to be significant. We can know a lot of things about what's happening from those numbers. All right, let's jump down to another example. Let's do 2y. And if you're watching this as a video, what I recommend is that every time I write down a problem, you pause the video like right now and try the problem yourself. And it doesn't matter if you get stuck or if you do something wrong, but it's very beneficial for your learning if you just try to do these things on your own before you watch me do it. Okay, so you've paused the video, you've tried it, maybe you were victorious. Let's see if you agree with me. If you're victorious, you can give yourself a high five in your own mind. If you were not victorious, you have something to gain, something to learn about, and maybe you will have a new question. So let's do this. We're going to do first 2y times 3y is 6y squared. Outer 2y times 5 is 10y. Inner negative 7 times 3y is negative 21y. And last, negative 7 times 5 is negative 35. That was first, outer, inner, last. Made that funny little face that sort of looks like a big nose, no eyes. You know, maybe I could put eyes here. Big old nose, and these ears that are the sides of the parentheses. Okay, let's simplify this because we can put these two guys together. 6y squared doesn't have any friends. 10 and negative 21. The y's match exactly, so we could put that together to get negative 11y. Again, if the positive and negative numbers mess with you, have a calculator at your fingertips. You can learn something just by thinking, backing yourself up with the calculator. All right, I believe I'm done with this problem. I've multiplied two linear binomials. I now have a second degree trinomial, and my leading coefficient is 6. My constant is negative 35. We're doing good. Here's another one for you to try. Again, stop the video as soon as I write this down. Try it on your own. It is so much more fun to do math than to watch math. Give it a try and see where you end up. Pause video and come right back. I'm going to work it for you. You're in control. First, 4a times 2a is 8a squared. Okay, remember, 4a plus 2a is 6a, but 4a times 2a is 8a squared because the exponent just tells me how many a's am I multiplying. Here, I'm just adding up 4 of these and 2 of these to get 6 of these. Here we're multiplying 4 times 2 is 8 and a times a is a squared. So keep thinking about that. Okay, that was my first term. Let's do our outer. First outer, this will be negative 36a. 4 times negative 9, and then a doesn't have any other a's, so we still have just a. That was our outer, and here's our inner. Negative 5 times 2a is negative 10a. And then last, negative 5 times negative 9. Negative times negative is a positive. 5 times 9 is 45. Okay, we often simplify here, so let's do that. 8a squared minus 46a, negative 36a, and negative 10a makes negative 46a plus 45, and we are finished with our multiplication. All right, I want to show you a word problem. This one comes up a lot. It says a contractor is building a deck around a rectangular swimming pool. This problem, you just see it in so many different forms here. Here's the swimming pool. It has a deck around it. In the middle part is the water. And there's a 15 right here and a 20 right here. These are in feet. A contractor is building a deck around a rectangular swimming pool. The deck is X feet from every side of the pool. Write an expression for the total area of the pool and the deck. So, X feet. So across here, from here to here, is X. From here to here is X. And that's going to be true everywhere. Like out to here is X, out to here is X. And let's talk about what that means. So here's the water of the pool. If I just wanted to know the area of the water, length times width would be 15 times 20, right? But I want to know the area of the pool and the deck. That would be all the way around this outside area, not the inside water area. So, what do I have? Well, I have 15 plus an X plus another X. So, X and X is 2X. So I could call this 2X plus 15. And that is my new dimension right there, okay? And then I can look the other way. I have 20 all the way across here, but then I need to go out X and another X. So that's another 2X. So an expression for this might be 2X plus 20. All right, so now I have a length times a width, or width times a length, if you like that better. And we can multiply this to simplify it a little bit. first, 2x times 2x is 4x squared. Outer, 2x times 20 is 40x. Inner, 15 times 2x is 30x. And last, 15 times 20. 15 times 2 is 30. And then we have to add another 0. So let's simplify this a little bit because we can put those together. 4x squared plus 70x plus 300. And that is an expression for the area of the swimming pool. Okay, so the 20, or the 2x plus 20, was linear, right? One dimension. And this expression was linear. It was one dimension. But when we multiply our length times our width, in fact, we kind of just neglected to even write that we were talking about feet times feet. So this is all going to be in square feet. Feet times feet gives us square feet. And so we now have a second degree trinomial expression for the width of this pool. And the cool thing about this is, let's say you're the contractor and you want to mess with the dimensions here, you can substitute any value you want in for x. You can say, oh, okay, what if I had a 1 foot deck? I could just put in a 1 for x and plug it in. Or what if I want a 2 foot wide deck? I could plug in a 2. And that's going to show me what the total area is for the pool and the decking. I could put in any number I want and mess with the amount of area that I'm using up for building the decking on this pool. So there's a word problem for you. Another way they often show this one as a picture frame, and they'll say, what will the area of the picture and the frame be? It is the same problem. All right, let me show you another type of problem that you're going to run into with these. Sometimes we don't get two neat binomials, and we get maybe a binomial and a trinomial, and it doesn't really matter. You can have any number of things to multiply. We don't typically talk about FOIL anymore because the pattern doesn't work as nicely. FOIL works with two binomials. In this case, we're just going to be very careful to multiply everything. So I'm going to start, it's just the distributive property. I'm going to start with 6x, and you need to be patient and careful and meticulously neat. You are going to multiply 6x times each piece in the other parentheses. So we're going to start with 6x times 2x squared, which gives me 12x to the third. Okay. We're going to do 6x times negative 3x, and that'll give me a negative 18x squared. 6 times negative 3 is negative 18, and x times x is x squared. And then we're going to do 6x times negative 5. 6 times negative 5 is negative 30, and then we have the x. So we're done with the 6x, but we're not done with the 5. The 5 needs a turn. You can draw your arrows over the top, underneath, it doesn't matter, but 5 is going to get to multiply times each thing in the other parentheses. We have 5 times 2x, which would be plus 10x squared. 5 times 2x squared. 5 times 2 is 10, and then we have the x squared. And we're going to do 5 times negative 3x, and 5 times negative 3 is negative 15, and then we have the x. And then let's do 5 times negative 5, and 5 times negative 5 is negative 25. There isn't even an x. All right, the next thing you have to do with this big long thing is combine like terms. So we need to find the things that go together. So first I look at the 12x to the third because that's the highest degree. This will help me get it into standard form. 12x to the third has no friends, but negative 18x squared does have a friend right there. So I have negative 18 and positive 10. That gives me a negative 8, and that was x squared. So remember, we're just combining like terms now. And then I find this negative 30 can combine with the negative 15x, negative 30x, negative 15x. That will be negative 45x. And then negative 25 is out here all alone like that. So I have combined this. I multiplied a binomial times a second degree polynomial, a trinomial, a linear binomial times a quadratic or a second degree trinomial. And notice what happened. I have x times x squared. I'm actually going to now end up with x to the third. So now I have a cubic polynomial, and I'm possibly talking about volume. Length times width times height is a 3D situation where you would have a third degree polynomial. All right, that pretty much wraps up our lesson here. Other than to get some practice in, let's just have one more practice problem. We'll do something that just looks a little messy and let you give it a try. Try this one. How about 11z minus 5y times 3z plus 2y. Again, pause the video, give it a try, come back. Let's do it together if needed. This is binomials. The binomials can certainly be just worked with the distributive property, where you would just do 11z times 3z and then do 11z times 2y, and then do negative 5y times 3z and then negative 5y times 2a. It's fine. FOIL is the same thing, maybe just in a little bit different order, and it sets us up to be able to deal with some mathematical situations that are in our near future. So let's just do this first. 11z times 3z is 33z squared. Outer 11z times 2y is plus 22yz. Can't do anything about x, y, z. They have to be the same variable to get exponents.